So week one will start. Week one, we have seen the basics. We have covered these topics in week one. How the computer interacts and what do you mean by program? Why do we have to program? Different basic data types, type conversions, and all these things we saw in the first week. Second week, couple of days back, we saw branching constructs, how a computer takes its course based on the true or false part of the condition. So that's what we have seen in the branching. Okay, today we'll see an interesting topic. That's looping constructs, very, very important. So we'll see looping constructs and unconditional control constructs in C. What do you mean by looping? What do you mean by looping? It's also called as iterating, or you can call it as iterating. It depends on your pronunciation. So sometimes we call it as iterating or sometimes iterating. So iterating. So what do you mean by that? Doing a job repeatedly. So that's what computers are also initially used for. Those jobs which have to be done repeatedly is boring for human beings. We use computers to do the jobs. We just hard code them, let them do it repeatedly for us without any lag in accuracy or delay. So looping is very important constructs which will allow us to make our piece of code run multiple times of conditions. Like we can make it run 10 times, we can make it run 100 times. Based on certain conditions, we can make a particular piece of code run as many times as needed. So that particular thing is called looping, getting in a loop, getting someone in a loop and making them run as many times as we require. So there are three looping constructs mainly we see in programming, C programming: for loop, do while loop. We also can categorize them as entry controlled and exit controlled loops. So that's one category. While explaining, I'll let you know what do you mean by entry controlled and what do you mean by exit controlled. We can also call it as event controlled and counter controlled. So these are different names which we usually use for looping constructs. And unconditional control constructs, the name only says unconditional, without any condition, moving from one place to another place. We are taking a path from one place to another place without any conditions. So that's why they are called as unconditional control constructs. So without wasting much time, we'll quickly jump on to the, so that I can illustrate all of them. Someone quickly acknowledge that my screen is visible.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, going to proceed. Have a statement, for example, I am printing it, I'm doing it, and I'll just run it. Okay, you can just got printed. The same job I want to do 5 times. So okay, you may tell just a 5 times. So why not go for writing it 5 times and then running. So you can see 5 times my job has got executed. But it's not a best way. Doing a same job 5 times, manually defining it in each single piece of code. Understand that this particular line is throughout same in all next 4 lines. So I have to write a logic in such a way that this has to get executed as many times I want without writing it separately. For example, 5 times is okay. If it's 1,000 times, then how will I do it? So in these cases where I have a piece of code, this is my single piece of code now, which has to be iterated. Code, which is repeating 4 times next. So it has to be repeated. I have to look once, you need to be doing it repeatedly as many times as I specify. For this purpose, we'll be going for looping construct. So we'll see how we'll actually go for looping that. So what I'll do is I'll simply write a for loop. I tell looping, right? I should be telling. I should tell him to count. Like how did I know it prints 5 times? Internally we counted, right? Once, twice, thrice, fourth, and fifth time. So in the same way, I should also make my system count. So usually you can make your system count. So in computer science, we start with 0, but in looping, it's not a rule that you should always start with 0. You can start counting with 1 also. But in computer languages, we actually don't neglect 0. 0 is very, very important when it is also. But in loop, you should start with 0. You can start counting from any place. So let me start counting from 1. My computer, go on counting until I reach 5. And each time I need to be incrementing myself. I need to be updating myself. I should be telling 5. See the meaning of this particular line. I'll just comment it and write here. It's having three things. The first thing we call it as initialization. We have a condition.
So I guess you're lagging a bit here.
Who is my computer? You should be any questions?
No, it's fine. Your voice was breaking in between before. Now it's fine.
Okay, fine.
Uh,
Yeah. I hope now it's clear. I can proceed.
Yeah, it's clear now. It's clear. Sir.
So I'm starting to count from 1. I'm making my system start its count from 1. Fine. But the system doesn't know who is this person I. So I should be telling that he's just used as a counter variable and he's an integer because I should my system int I because my computer doesn't know who is this person I have used him, but who is it? So I should just tell my computer it's an integer variable. He's just used for maintaining the count. How did we count in the previous step is our brain was used doing it background, correct? How many times are there? 5 times are there. I easily know 5 times I have written it. But computer doesn't know like that. So we need to give him a variable which counts on behalf. Fine. So I've given a variable I which starts with 1, then or equal to 5. If I give just less than 5, it counts till 4. 1, 2, 3, 4. So I should be giving less than or equal to 5. It is same as giving I less than it is equivalent. These two lines are equivalent. I less than or equal to 5. So it's one and after printing, I have an end statement. After printing, I have a end of brace. So it's not telling that come out of the loop. It's telling check the updation and check the condition once again. So what happens is after this printf semicolon, if I have come to the ending braces of this block, it again goes to the updation part. It searches for the updation part. What is the updation part? I plus plus. So what happens in the next line? My I value, I printing I become again I'm checking whether 2 less. So it will enter the block if the condition is true. It will print high. After printing high, again the procedure continues. It goes for updation. So what is the updation? I is equal to 3. Again, it is true because 3 is less than or equal to 5. It prints high. For the next one, so I is equal to 4, less than or equal, it's true, it executes it, and it prints high. Next time, again, it'll increment itself, it will increment it to 5, it will make it as true because 5 is equal to 5, and the condition says I less than or equal to 5, so it is again true, it tells high. And it increments, so I will become 6. Now see here, when I become 6, when it checks the condition, 6 is not 5, so it is false, so it is false. When it is false, it comes outside. It stops itself. It stops here. When it is false, it stops itself. It comes outside. So coming outside means there is nothing to do. So by the time it has finished this thing, you can see how many times high has got printed. It has got printed 5 times. So let me comment this and show the output to you. I'm going at a very basic level for the freshers. So those who already know the concept, please ignore or bear with my. Okay. So you can see here, 5 times my high has got printed. So this is what is a procedure. For ends, 2 lines again chucked. It will print this, go to the updation, and then check the condition. If the condition is true, again enter. Do the job, again go for updation. Check the condition, enter. So this process goes on continuing until this condition fails. And every loop should have these 3 things: initialization, condition, and updation. Sometimes we don't write int I here separately. You can also write it here. That is also working. The line uses a counter variable called I and its type is integer. You need not specify it outside. Within the loop, I'll run and I'll show you. You can see here the same result. Int is just to specify that I'm using a variable who is used for counting. So this is my for loop, which is printing high. As I was explaining, what do you mean by looping? Doing a job repeatedly, doing a piece of code repeatedly, executing the things repeatedly. So when we have to tell executing the things repeatedly, when we also do the things repeatedly, we count in our the same way for computers also, we need to provide them someone to count. So that's why we are giving this count variable. So their job is to make sure that they're counting regularly, and when they're doing the job also, next time they have to update the count. In the same way, when we tell about loops in computer science, we have 3 things: initialization, updation, and condition. So initialization is what we do before entering into the loop. Condition is before entering into the block of the loop, that is the body of the loop. And updation, once we finish the task and again check the condition. So that's a for loop. And in the for statement itself, we are having all the 3 components, that is initialization, condition, and updation. And this is your body part. For loop. I was telling the while loop by comparing it to the for loop. As I said, any looping construct should have these 3 components: initialization, condition, and updation. So if you see my while loop here, I've written. So it has an initialization for loop. You can see the same initialization what we have written for loop, int I equal to 1. And I have a condition, I less than or equal to 5. And I have done the updation at the end of the body. And when I run, see, I'm getting the same output as I was getting using for loop. So this is my while loop. Same way, let me go for writing the next loop, that is do while loop. Okay, look into that. I'll be writing int I is equal to 1. Do the task. High. Printing high. And then I should have the updation. Condition. Yes. So this is my do while loop construct. Fine. So see the syntax here of do while loop. I have the initialization here. Initialization is here. Here. Fine. And I have the condition here. Have the condition here. All the 3 components are there, but the way how they are coming is different. If you compare this and my while loop, first initialization, condition, updation. For loop also was the same thing. First initialization, condition, updation. But if you see the do while loop, first initialization, update, and then condition. So this is the difference. But since I have coded all the 3 to do the same task, it will be giving the same output. But I'll show you the difference with an example. But when I run this program, you can see the output. It's giving all 5 high. Same output has been given. Okay. Now the meaning comes. What are the 2 terms which I used was controlled, and another was exit. The name only says someone is controlling during the entry, and exit means someone is controlling during the exit procedure. So in entry control, we have two loops, for, while. In exit control, we have do while. Okay, why do we call them entry controlled? The condition is coming before entering the body. The condition has to be checked and then I am entering the body. So that's why it is called entry controlled. The condition is checked on the entry. If you see the for loop also, the condition is first checked after initialization. Then I am entering the body. But if you see the while loop, I'm entering into the body part. When I'm coming out, I'm checking the condition. That's why it is called as exit controlled. Okay. One more differentiation what we can give is categorization. We can call it as, and then event controlled. So in counter controlled, we have only one loop, that is for loop. In event controlled, we have, what are the two loops, while and do while. I'm just giving you the different names of it because sometimes in questions it control loop or use a event control loop. So now why the name is being given for as counter controlled. If you see the for statement clearly here, into this particular line, you know how many times the for loop is getting executed. There is a clearly a counter fashion used here. Okay, I is equal to 1. Then I have to check the condition. Then I is incremented 1. So 1 by 1 by I is getting incremented. So there is a counter variable used, and clearly it's been used for procedures where we can easily maintain the counter dependent on the body. So in that place, we call it as counter controlled. But when it comes to while, the counterpart is actually being taken care in the body. The body is responsible for telling how many increments are happening or how the increments are happening. That's why it is called as event control. Some event is happening within the body, which is responsible for the count. It's not like that. The statement itself is having the counters in such a way that by looking into the statement without looking into the body, you can come to know how many times the loop is getting executed. That's why the names have been given like this. Just the names, remember, that's it. Event control. Why event control? Because some event has to be happening in the body, which is responsible for changing the counters. It's not the statement which is responsible. It is this particular part which is responsible. So this was just the basics on how do we use the syntax of the three loops. Fine. Okay. So let me show you the syntax once again. This is a while loop, a for loop, and this is a do while loop. Okay. Going forward, what are the different variations what I can have? Okay. How did I write my while loop? If you see here clearly, I have initialization, I have the condition here, and I have the updation coming in the body at the end. I can make my for loop mimic as a while loop. How will I do it as int I? Before that, let me write a for loop and show you for int I equal to 1, I less than or equal to 5, I plus plus. Okay. Enter percentage. Let me go for high itself. Okay. So see the for loop, as you know, it prints 5 times high. So let me run it and confirm it once again. It prints high 5 times. Okay. Now see, it is the initialization here, condition and updation. I can cut this initialization part, bring it here. This is also valid. It's not wrong. I'm cutting the initialization. I'm cutting from the for loop, and I'm writing here. This is initialization. So my for loop is having just now condition and updation. But remember, you're just cutting the initialization part. Don't remove the semicolon. In for loop, semicolon is compulsory. Now let me run this. Most of you may feel it's an error, but it's completely valid. See here, I'm getting 5 times high. I'll remove this updation and I'll put my updation here. Initialization. My condition has come here. Here. Now let me run this. See, high has come 5 times. So these are the variations in which I can have. It's not compulsory that I should have all the 3 in the same line for loop, but compulsory things are 2 semicolons. If I don't write semicolons, that means it's an error. Because if I don't write first semicolon, it is thinking this as the initialization. So now nothing is there in front of the semicolon. So it thinks that it has been written before. And nothing is there after the semicolon. So it thinks that the updation comes next. Anyone is asking any question in the chat section? If I would have missed anything, is there anything
Yes,
in the chat section?
there was. No, you can't see the previous. The question was, why do you put why do you put a semicolon after the do while statement after the while?
Yeah, okay, yeah, that's a syntax of it.
So you're lagging again.
Again, I'm lagging.
Now it's fine, I guess.
Yeah.
Now I don't have any place to go. Now I'm in the terrace now.
I guess Rachita, you are lagging.
Okay,
It's not
fine.
lagging.
Then
It's
I'm
fine.
Okay,
now.
sorry.
now. I'm at my top of my house now. I cannot go anywhere else. Okay, let me proceed. Fine. Okay, I'm not lagging. I'm assuming. Now, quickly, I have few questions. The while loop is used as a statement. Okay, that's the answer. I feel. Why do we use a semicolon in the do while? Okay, it's a syntax. This is the only construct among the 3 loops which having in its statement as a semicolon. Because if you see the for or while, I'll just show you the for or while. If you see the for also, it doesn't have a semicolon in its statement. If you see the while, it doesn't have a semicolon in its statement. But do while is the only construct semicolon. I'm clear? Am I clear? I want confirmation once again because
Yes, sir, yes, sir, yes, sir. It's clear.
it's not lagging right now.
No, it's not lagging, sir.
Okay, fine. So this is the syntax of it. Do while is the only looping construct which is having a semicolon in its statement. Statement in the sense I tell is this one. This is a statement. While, for, do while. So these are constructs in which this one line is actually being quoted as a statement. And this is the only loop which is having a semicolon to end its construct. Fine. Okay. Now coming into difference, because most of you have the question here, because you can see here, all the 3 are doing the same job. The same job of printing 5 times high. For is also doing the same job, and do while is also doing the same job. So what is the difference? So before coming into difference, I was just telling variation of for loops. So you can see here initialization, I have written it here. There is no condition, and I have an updation here below. Okay, let me run this code. High is going on getting printed. You can see it. It's not stopping only 5-6 times. You can see I can drag it. It's going on getting printed. And it's a runtime error. Why? Because there is no one to stop printing high. To stop printing high. So it goes on printing high. There is no one to tell stop. So such kinds of loops, we call it as infinite loop. So what's the way of stopping it? I just have to write equal to 5. So if I write I less than or equal to 5, when it reaches 5 count, you can see here the loop has stopped. There is no error. Earlier you were getting a runtime error and it was going on printing because there was no one to tell stop. So is there any other way how I can make it stop? Okay, one of the ways I can also write a if loop, if branch inside the for loop. I can write if I is then or equal to 5, then stop. This is also one of the way. So what usually questions it comes is, instead of directly giving a for loop, see the question it would have come like this. They would have given a for loop and asked you to guess the answer. Everyone will do. Everyone will tell it prints high 5 times. But they little bit complicate the question when it comes to your campus drives and all. What they do is they go for complicating your questions. So what they did is the same loop, they wrote it in a different way. So you can see the initialization part in the beginning. there is no condition part statement, and there is no updation in the statement. Condition is being written in the form of an if, and the updation is there in the last part of the body. So it looks somewhat to your while loop. So now let me run the code. It prints the same hi 5 times. Sorry. Right. Okay. Now see that carefully. First time I is equal to 1. There is no condition. It is checking whether I is less than or equal to 5. If it is less than or equal to 5, it has to print. It has to print this. Fine. It has to print high, and then it goes to increment. So if you see here, I'm getting an error. So what is the reason for getting this error? I have written a if to stop. I'm not told him to stop. So what I'll be doing here is inside the if, I'll just be writing another statement which is called as break. What I mean by break is stop whenever you see this particular line if it's a looping construct. Break works only for looping constructs. So let me run it now. You can see here. Now hi has got printed only once. What is the reason of it? First time I is equal to 1. There is no condition. Inside it comes. So what is it doing? I less than or equal to 5. Yes, because I is equal to 1. So 1 is less than or equal to 5. True. So what it does, it goes inside. It prints hi. After printing hi, it is having the next statement break. The meaning of break is come out of the loop. So this is how I actually come out of my infinite loops using a break. That's the only way how I can come out of my infinite loops, by using break. So you can see here it is printed up. Now how do I make it print 5 times? So what I do is if I not less than 5, if I is equal to, or if I is equal to, then only let it come inside and break. So I'll write this line also outside. The first time I is equal to 1, there is no condition. It will check here. Is my I equal to 6? No, because I is equal to 1. So it will not enter inside the if. It will not enter inside this. If it will come out, it will print high. Then I plus plus. That means I becomes 2. Next time there is no condition, it comes inside. 2 equal to 6, again false. So it will not enter and do the break thing. It will come out and do the printf. So now if I run this particular problem, you can see your high getting printed 5 times. This was the equivalent code of your for loop, which we had written earlier. The for, while, all those things which we have written earlier, the equivalent code, you can also consider this as its equivalent code. So I have used an unconditional construct. As I said, break is an unconditional construct. Why it is called unconditional? Why is it called unconditional? Because you can see here, without any condition, there is a condition. Correct? There is a condition for if. But if you see the break, there is no condition. Without condition, I am making my computer jump from this line to outside. So that's why it is called as unconditional construct. Okay. Coming into difference between different kinds of loops. Let me go for that. Show you the difference with one piece of code. I is equal to 1. While I greater than 1, printf hello. Okay. Or not to confuse you, let the use less than or equal to 5 itself. But initialization, let me take it as 10. I plus plus. Okay. To see the problem here, first my I is 10. Then I'm checking 10 less than or equal to 5. It's false. So it never enters it to the while loop. It never enters into the while loop. If I write some other statement here, printf outside. And if I run my line, outside. Okay, I missed any semicolon. Yeah. There's the semicolon, so it was throwing an error. Let me run it once again. Okay, so you can see it here. It is printing just outside. It never entered into my loop. Why it did not enter my loop? The reason is my condition is not satisfying. My body, my condition should become true. Correct? That's why it was not entering. Okay, now see the difference. I'm converting this to a do while loop. What is the difference between do while loop? The while comes here. I'm just writing do here. I've not changed anything. I've just replaced the lines. The while comes at the end. I've written do. Previous output, it is still here, just outside. But now see the output. Hello, and then it prints outside. See? Hello, and then outside. Here also the condition is failing because your I is not less than or equal to 5. So that's the difference between while and do while loop. It is exit controlled. Whatever may be the condition, the body will execute minimum once in do while loop of it. Without checking the condition, the body always gets executed first time. After executing this, it checks the while and where it fails. Where it fails. That's why you can see the print getting printed only once. The printf getting printed only once. Hello is getting printed only once. But had it been a while loop, how did we write the while loop? I'll show you here. This was our while loop. If it has been a while loop and if I run, it just prints outside because it never enters inside the while loop. See, just outside. Because before entering, I have to check the condition. But do while is not like that. The condition is checked after doing the job for minimum one time. For minimum one time. So, see the difference between do while loop and other loops. In do while loop, irrespective of the condition, the loop gets executed minimum once. But in while and for, the condition has to become true. But it's not the case for do while loop. Minimum once, it surely gets executed, whatever may be the condition. That's one thing. Okay. Now, most of the questions what you have is, why do we write for I++? Int I is equal to 1, I less than or equal to 5. Only I++, or can we have something else? Let me show that. I\n. Here, this is what we have seen earlier. 5 times my high statement has to get printed. Okay, so it is getting printed. Okay, now we'll see the variation here. What do you mean by I++? The meaning of I++ is increase the value of I by 1. That is nothing but I is equal to I plus 1. I plus 1. What was the previous value of I? You add 1 to it and make that as your new I. Previously I was 1. I++ will add 1 to that and it will give the new value. That means I will become 2. So it is also equivalent to writing ++ I. We'll see the difference here. I'll not write I++. Let me write ++ I and run the code. This will also print your high 5 times. See, it's also printing your high 5 times. Okay, yeah. Now, can there be written only I++ or ++ I? Anything else I can write? You can also write I plus equal to 1. This is called shorthand assignment operator. And write it down. What do you mean by that? I plus equal to 1. I equal to I plus 1. I equal to I plus 1. So if I write I plus equal to 1, it's called shorthand assignment operator. The meaning of that is I equal to I plus 1. Similarly, if I write I minus equal to 1, the meaning of that is I equal to I minus 1. See the difference? Why it is called shorthand assignment operator? Because I'm not writing it as two different blocks. Like you can see this side, I have written first I minus 1, then it is given to I. So instead of writing it in a lengthier fashion, I'm writing it in a shortcut. That is I minus equal to 1. What is the rule is to write shorthand assignment operator? Your left side operand and your immediate right side operand should be same. Both should be I. In that case, I can write shorthand assignment operator. So I have written shorthand assignment operator here. So let me run. See, I is getting printed 5 times. All of the different variations of it. So next, what is the question arising is plus and plus plus I same. Okay. So let me show that using simple increment and decrement operator is what I'm referring now. So printf percentage %t backslash n. And let me write a is equal to I. Your reference, let me write a is equal to backslash n. The same way, let me print I also. Instead of a, let me print I also. Okay. A simple program which I've written here. Initially, I have int I, so let me give him a value as 7. I gave him a value as 7. Then I'm writing, that means whatever is there in I is given to A. So what happens? 7 is there in I, so it's given to A. So A also will get 7. Then I'm printing percentage D. I is equal to percentage D. Why percentage D? It's an integer. And this is a new line character which I've given backslash n. And these are the variables which are used for printing the values in an integer format. Okay, A is not declared. So see the error. Once you see the error, it's very carefully you should read the error. Don't directly go to the program. Read the error, and you should have a capability that by looking into the error, you should be able to understand it and solve it. Clearly, he's telling, see, you have told someone as A, and you're giving him I, but you did not tell what is the type of A. You are not declared him. To tell that he's also of type integer. He's also of type integer. I can actually do it in 2 steps also. Here I can write A equal to I. I can do it in this way also. Now that error goes. That was a simple error. See, A is equal to 7, I is equal to 7. Both are same. Now see the difference. I'm writing A is equal to I. What I've done here is, this is called post increment. Post increment is, first it will give A is equal to I. This is the first step. Understand carefully. This is the first step. It does it in 2 steps. What is the second step is equal to I plus 1. So it does 2 jobs. What is the first job? Whatever is there in I is given to A. So what was there in I? 7. So 7 is given to A. It will increase itself. So I will become 8, but A is given as 7. So we'll see whether it is correct. Tell once again after seeing the output also. See here, A is 7, I is 8. Getting the difference? This particular line, computer takes it in 2 steps. What it is doing, it's giving A with the old value of I. What was the old value of I? 7. My computer is performing I equal to I plus 1. That's why A has got the old value 7, I has got 8. Okay, this is 1. It is called post increment. Pre increment, write A equal to plus plus I. This is called. It also does in 2 steps. But here the steps are, first your I is equal to I plus 1. And the second step is A equal to I. See the difference in post and pre. What do you mean by pre? Before first you do this part and then you give the value to A. So what first he is doing? I equal to I plus 1. So I would have become 8 to A. So that means both A and I are having 8. So let me run this. Both A and I are having 8. This is what is the difference. So when will you see the difference? Whenever they are being given to someone else. But in the for loop, they are not given to anyone. That's why both of the statements are correct. If you write I plus plus, or if you write plus plus, are same. When you write it as independent, the variation comes when you're trying to give them to someone. So when you're trying to give them to someone, post increment will give the old value and then increase itself. Pre increment will first increase and give the new value. Difference between post increment and pre increment. Computer does it in two ways, two jobs. Operators involved, assignment operator and increment operator. So computer always does it in two steps. Which one to do first? That depends on post and. This is what is a concept of post increment and pre increment. I hope this example should help you out. Run it multiple times by yourself and you'll get the difference, because many aptitude questions come in this section, post and pre increment. I'll not complicate things with this. Let me go forward with the session now. That's the variation. Fine. Now coming into control statement. See the statements here. Let me write printf semicolon printf statement 2 semicolon printf statement 3. Couple of printf statements I'm writing to show you the next concept. Statement 5. Okay, there are 5 statements I've written. So very simple, one after the other, each of them get executed. So we'll quickly see that and then proceed with their explanation. Okay, statement 1, statement 2, statement 3, 4 and 5. It looks shabby, so let me give a, everyone comes in a separate line. That's the use of new line. It's just a formatting. The value does not change. Only thing is it leaves a new line before going to the next part. Damn it. Yeah, now it is very good to see also. Statement 1, 2, 3, 4 and 5. Going here. After second statement, I'm writing go to L1. I've just written a name called L1. I'm writing L1 colon. Just see the difference. First, it will come to statement 1, it will do the job, it will print st1. Then it comes to statement 2, it will do the job, it will print st2. Then what I've written, go to L1. Without any condition, I'm directly telling him go to L1. So when I do this, it will search for the name called L1, where is it present. So directly it will jump from this line to L1. So what will be your output? ST1, ST2. It will skip ST3 and ST4. Directly it will print ST5. So we'll see that. ST1, ST2 and ST5. 3 and 4 are skipped. This is called jumping in C. You're jumping directly from one line going into other place where that label is given. This L1 is called label. Now we have used a forward jump. I'm jumping forward. I'm going front. Same way, you can go for a backward jump. You can go for a backward jump. So what I'll do here is, I'll comment this. Go to I'll remove this label here, L1 colon, and let me write it here. Go to L1. See carefully, it's very dangerous of using goto. Why? I'll tell you now in this example. First, it will tell st1, it will print. Then it will print st2 because this is just a label given, a name given. So nothing to do with this printf. So it will print st2. Then it will print st3, st4, st5. Then what you're telling, go to L1. Again, it goes to L1, print st2, 3, 4, 5. Again, you're telling go to L1. So this process goes on continuing. Down, you're sending it up. When it comes down, you're sending it up. This is called backward jump. Backward jump in C. Let me run. This is an error because the system does not stop. It's an error line. It's a runtime error. See, it goes on printing st1, st2, st3, st4, st5. Again, it goes to L1. That is st2, 3, 4, 5. Again, 2, 3, 4, 5. So you can see here that 2, 3, 4, 5 goes on printing. So that's why it is throwing us an error. Error. It's called infinite execution. One you have seen in loop, one is this. That's why you have to be very careful when you're writing goto. So you may have a question, then when are we using goto? Okay, this is a backend of coding what we are learning. If you would have seen some websites, you or everyone will have a Facebook account or anything like that, or Insta or any account. If you press home, it will directly go back to the home page, right? It will come back. You would have seen. If you press home button, it will directly come back and you can see the news feed, the new news feed getting in. That's nothing but backward jump, because in the backward jump, it would have kept the latest news. So that's the backend code which they would have used. So you would have seen in some places, you are there in some other tab, there is a home symbol, you click that, it comes to the home page. You're coming back. Website, you will always start with the home page. Then you would have gone to other pages. Suddenly you click the home button, it brings you back to the home page. That's where in the backend they would have used these kinds of code. Without any condition, go back to the first place. That's why these are very, very useful. It's not that they're not useful. They are very, very useful. In other languages, we use it with the help of functions. We can call the functions backwards. So other procedures can be used. But C was the initial language designed for doing these kinds of things. That's why you can see these constructs like goto and all. But you should be very careful. As I said, it will create this kind of problem. Your computer gets stuck. Stuck because I'm using a compiler at the back end to learn the programs. But when you do it at server level or when you do it at a deployment level, your system gets stuck because it doesn't throw a runtime error. It thinks that you want to do it multiple times. So it goes on doing and your server gets stuck. So you should be very careful with these constructs, especially unconditional control constructs. Break, continue, and go to. Very, very careful while execution. And these are very important also in terms of your coding is considered. So this is your go-to. There are two kinds of jumps: forward jump, backward jump. Forward jump may not infinite your execution, but backward jump, maximum it will create your program to run into an infinite execution. So be careful with that. Okay, now we'll erase some of them and then we'll go for the break. Let me go for illustrating break and continue. Yeah, so they come in a loop. And always remember, break and continue. These two things are applicable only for loops. Break and continue are applicable only for loops. It's not applicable to branching also. They're applicable only to loops. So we'll see in the loops what you mean by break and continue. So I is equal to 1, I less than or equal to 5, and then I plus plus. Okay. Let me go for printf. Okay. See, one more thing. What I'll do is I'll put %d and then a new line, and let me go for printing I itself. Let me go for printing I itself. So what happens? First time it comes initialization I is equal to 1. So it checks the condition I less than or equal to 5. That is 1 less than or equal to 5. It's true. So it comes inside, it prints %di. So what is there in I? 1. So let us see it here. First time, my I value is equal to 1. So it will check the condition. The condition is true. So it will display I. So let me write P1. P1 means printing 1. Next, after printing 1, it again goes back I++. So your I will become 2. The condition is again true. See there carefully what I'm doing. First, this was the initialization which was done only once. This is your value of the variable, which is in the first place. When I am checking, I'm writing the condition. So I'll just write C. This is a condition. Then I'm doing the body part. Writing it. This is called tracing. If it was very difficult to write all those things in chalk and board, it was very easy. We can write. So that's why I'm using this kind of comments to explain. So what's the value of I1? Condition is true. Condition means this one, I less than 5. So 1 less than 5, true. Body is printing 1, so it prints 1. Next, your I will get increased. So value of I will be 2. Condition is again true. So what it is going to do? It's going to print 2. Same way this procedure continues. Next time, what's the value of I? 3. Again, the condition is true, so it will print 3. Again, it will increment itself. So I will become 4. Condition is again true, so it will print 4. Next time, your I will increase to 5. Again, condition is true because 5 is equal to 5, so it will print 5. Next, when it goes, your I will become 6, but your condition is false. So when the condition is false, it has to come outside. So what it is printing? 1, 2, 3, 4, 5, and then it has to stop. So we'll run and we'll see. One, two, three, 4, 5. Then it is stopping. Now see the difference here. Let me write one more printf for explanation. So printf hi, then I'll just give a space and I'll semicolon. So what happens? It's printing. First it will print hi, then it will give a space, then it will print 1. Same way it happens for here also. It will print hi, then 2. And then it will print 3. It will print hi and then 4. It will print hi and then 5. So you can see here the same job of printing hi and then printing the value of I. It's done 5 times. So if you see here, output is hi 1, hi 2, hi 3, hi 4, hi 5. So the job. Okay. Now see the difference here. I'll just use a statement called continue. I've not used anything. Just I've introduced a statement called continue. What happens is here, I is equal to 1. So it prints hi. Then what it sees? It sees continue. The meaning of continue is skip everything which comes after this and directly go to the updation. So it will skip this printing 1. It will not print this 1. It will just print hi. It will go to the next line. What is the next step? I equal to 2. Again, condition is true. So it prints hi. After that, you're telling continue. Again, it will skip 2. So again, it will skip 3 also. It will skip 4 also. And it will skip 5 also. What do you mean by skipping? When it is skipping, as soon as it sees continue, it will not do the jobs until the closing braces. It will directly jump from this place to updation. So it is doing here only. It is stopping your control to go to the next part of the body. It's avoiding your control to go to the next part of body by giving continue. I'll just run this program. See, hi. That's it. It's not printing I value because of this continue. If I comment this continue, hi 1, hi 2, hi 3, hi 4, hi 5. So 5 times it comes, correct? Looks awkward telling hi 5. So let me write hi 5 only here. So This is how it looks. That is what is the power of continue. Making your body part skip. Some of the body part is skipped. Fine. Okay. This is no condition. There is no condition I'm checking here. You can see here. No condition. Just have written continue. It is skipping this line. Okay. Still more dangerous is this person. I equal to 1. Condition is true. Print high. Then it sees break. It will never do the other things. It will stop your loop itself. So you will only see your high getting printed once. See? It has prevented you from continuing the loop itself. It has stopped your loop itself. But continue was not like that. It was not stopping your loop. It was skipping the next line. But break is not like that. Wherever it sees break, your system sees a break, your compiler sees a break, it will come out of the immediate for loop which is available. So it comes out of the for loop. So that's why you can see high getting printed once. Had I written this break here, then first I equal to 1, it prints high, it prints I value, then break. So you will get only high and then 1. See? Okay. To confuse you, they usually give the question like this. Continue. It is meaningless. It is meaningless. Why it is meaningless? You're telling skip the next part of the body. What is there in next part? Nothing is there. So see the answer. It prints correct answer. High 1, high 2, high 3. It should print that. See? No change. You're seeing. Why? You're telling skip the next part of the body, but there is nothing to skip here. It's a blank, nothing to skip. Had it been something written there, it would have skipped it, but there is nothing to skip. So they just have given this to confuse you. So most of you will end up by writing the answer as high and 1. It's wrong. It is doing all the job. It's not skipping anything. High and 1 will be the answer if I give not continue here, if I give it as a break. Break will not continue the loop. It will stop the loop. Continue will continue the loop, but it will skip the part of the body which comes next. See the icon? So this was your basics of what I've given. Without going into much, I've just covered the basics. Let me go for a few problems where real-time problems where we see these loops. Before going in, I just quickly want to take a few questions in the chat section if it's there. So let me go back to the chat section. Okay, I hope most of the questions. Any questions which is not answered? What is the difference between return 0 and get ch? Very important question when you're working on Turbo C. I answered it in the first week, but let me tell you orally what is the difference between return 0 and get ch. See, what happens here is main. Whenever we tell a C program or any programming language, one program is must. That's a main program. In some programming languages like Python, you don't see the main program, but it is the first piece of code, whatever you write, basically taken as main. So when you see the objects and all, when you print the objects and all, it will be printing main and all in Python. Those are using Python, because most of you may tell in Python we don't have main, then also it is working. It is there, but you're not seeing. Wherever you're writing your first scripts, right, that is only by default taken as your main. So in C program, it's not like that. We need to be writing it in the procedures. So C is always a procedure-oriented language, function-oriented language. Always you should have functions, fine, to do it. So main is a first function for execution. So what happens is the whole computer is actually being operated by or controlled by OS, operating system, of your computer. Heart is very, very important. CPU is called brain of the computer, but operating system is your heart of the computer. Fine. So what its job is to give you CPU, give you memory. So for example, there are 10 jobs which you're giving it to your computer. Which job has to be done first? That is also being taken care by this. So we tell that it is responsible for scheduling. And security, updates, all these things, the major jobs of your computer is the responsibility of operating system. And to do this, it takes the help of antivirus softwares, compilers, debuggers, linkers, and many other softwares. It takes the help of it. But very important is operating system. In a C program, your operating system knows that your program starts from main and ends in main. Your program starts in main and ends in main. Yeah. Okay. Whenever I write int 0, since it's an online compiler, it may not throw me an error also if I don't write, but it's a habit of writing return 0. So what is the 0 standing for? 0 means success exit. Whenever your execution is successful, you have to return this 0, and this 0 will be sent to your operating system. So when the operating system sees 0 from this program, it comes to know that the program was successful. The program was successful. But if you're using your offline, you can write void. When you write void, you need not return anything. You write void, you need not return anything. But in Turbo C, what happens is you have to write get ch. We usually have a habit of writing get ch. Why do we write get ch? The meaning of get ch is get a character. What happens in Turbo C is when you execute a program, the output comes and it goes for fast. You cannot see the output. It comes and goes off in a fraction of a second. You should make your output wait in the screen. So you are giving this line. What you're telling, get ch. That means your output will be waiting until you get a character. That's why we usually press enter key, then it again goes back. And this problem comes only in your Turbo C compiler. In modern compilers, we don't use get ch. In modern compilers, get ch means you're waiting for a character. But in Turbo C, what happens is, if someone was using Turbo C or anyone from SOSC who is experienced, once the college starts, you can execute and show. Or if you're having any Turbo C compilers, you can share your screen and you can show it now also, no problem. Because I don't have Turbo C in my system, so I cannot show it now. If you have Turbo C, you can encounter this problem. The output comes and goes off. You cannot see the output. It's a fraction of a nanosecond where the screen will appear and go. So you should make your screen wait until you press something. That's why you're giving get ch. Same way your output will go on getting printed on the screen. So you should also go for erasing your output. So we used to give CLR, SCR, clear screen. Means before starting the program, erase the board. Like before writing the new output to your output screen, erase the previous output. That's why we usually write clear screen beginning. And get ch we usually write at the end. Means wait until I give input. So this is what is the difference of get ch and clear screen. We don't use it in modern IDEs. Only in Turbo C you will encounter a problem where your output will go off fast. So you should make your output wait until you press something. That's why you give get ch. And return 0 is always compulsory whenever you have your function returning any integer variable. If you write int, it should return an integer. If you write float, it should return a floating point. But main returns an integer 0, which stands for successful execution. That's what is that. I've explained it in the first week also. Okay, maybe you've missed it. Everyone has answered that question, so you don't have anything to answer. How do you decide which loop has to be used while writing? Okay, very good question. Chirag AK. I have told all loops are doing repetitive tasks. Which loop to be used? How do we decide it? It depends on the problem which is being given. So I'll give you a few problems where you will come to know which loop has to be used. Your Fawaz has answered it. It depends on your problem. That's coming by experience. That comes by experience. When you have written multiple programs, right? It comes by experience, like which one to do it, which one to use it. It doesn't come as it is. You cannot go first time. Whoever has learned program theoretically cannot tell should I use a for loop, while loop, and all. It comes by experience. So don't worry about it. Like for now, most of you are confused. Like my friends or my lecturers are writing the program in one stretch, but we are not able to write it. It's only because of experience. It comes only because of experience. Number of hours you spent with your system coding, that defines your speed of coding. Okay, \T means a space, tab space. It's been answered. Okay, I don't have any questions to answer. I guess everything is answered. Stopping your code, that's it. That's very dangerous to be using in your servers and all, it abruptly stops the resources. Tell students anything. See, break stops the loop. Exit will stop the program itself. Break is actually stopping only the loop. If I write break and if I write here printf hello, it prints hi one and then it comes and prints hello. Let's see, it prints hi one and it prints hello. Instead of break, if I would have written exit, the status for exits. If I write exit, it will stop my whole program itself. So don't use exit. As far as possible, avoid using exits, because deployment level using exit is very dangerous because it blocks your resources. It creates a deadlock state at some places. You learn all these things in your upcoming semesters. What do you mean by deadlock and all? One wants to be going fancy. Okay. Sir told plus plus I, and sir also told I plus plus. So can we go for using plus I plus? We don't have this syntax actually available. So don't go for using it. You cannot use plus I plus. It's not identified by your system. Plus I stands for unary operator, means telling positive. Identified by your computer. Plus I, it knows it's a unary plus, but I plus it doesn't know. Okay, nested for loop. If you write break statement, will it break both for? No, it breaks only the inner for loop. If you have written inside the inner for loop. That's why I said break is applicable to the which is coming. It's not applicable to all the loops. It's only applicable to the immediate loop which is coming. Okay, one simple question I'm getting. What do you mean by percentage d backslash n? Percentage d is used for printing an integer. Percentage d, it's my job to give an integer in the variable section. So what is that integer I'm giving? I'm giving I. So what is I value? I value is coming from the counter. Okay, hope I've answered all the questions. Hope there was no delay in the last 45 minutes odd. Volunteers, hope I'm on sync. There is no delay and it's going on fine.
No, sir, it's been fine. It's been really good.
Okay. But it's worst when it comes to terrace. It's okay. Yeah, we'll proceed with the things and then we'll try to wrap it up. Now we'll go to the section of problem solving. Very interesting problems. Try to fetch few problems which are interesting and then give you. I've given the questions already to the volunteers. I think they'll be sharing it soon. But before that, we'll see few questions. Okay, one of the question is very simple question which we usually begin with this. Someone gives you a number 1, 2, 3, 4. 2, 3, 4, 5. You need to find the sum of the digits of this number. That means 1 plus 2 plus 3 plus 4 is 5. 50. Correct? Someone is giving you a number like this. 1, 2, 3, 4, 5. You should tell the answer 15. If they give 1, 2, 3, 4, 5, 6, you should tell the answer 21. So it should go on like this. You should go on adding the digits. Go on adding the digits. Okay, so the problem will be thrown like this. This is called use case. They'll give input. They'll not tell the process. They'll tell output. As I've given in your question rounds also. In the question also will come like that only. When you see in CodeChef or any online data camps, they usually give use cases. Use cases will have two things, input and output. And the question sometimes will have hint section and all those things, but usually use cases will have input and output. So input is this one, your output is 21. Any number they give, you need to add up the digits and then give the answer. So when the question comes like this, immediately you should be experienced enough, or you should be having your common sense that, okay, it's not the job of doing once or twice, it's repeatedly adding something. For loops, that means I should go for loops. Now the question comes, how do I make my computer understand this? How do I make it understand this simple thing? Okay, Okay, so what I'll do here is I will be using just mathematics. 1, 2, 3, 4, 5. Excuse me. 1, 2, 3, 4, 5. One concept I know. If I divide by 10, always my quotient is 1, 2, 3, 4. Everyone has to agree with this. It's a maths which I'm telling. I hope you know what I mean by quotient and remainder. And my remainder is 5. This is for sure in maths. Please tell. If I divide any number by 10, I'm telling integer division. Don't tell sir is going wrong. It is 1, 2, 3, 4.5. No, I'm just telling integer division. Fine. In computer science, we have integer division, right? So I'm telling that part. The quotient is 1, 2, 3, 4. Remainder is 5. I'll not take the previous number. I'll take the previous quotient. So what is it? 1, 2, 3, 4. The previous quotient. 1, 2, 3, 4. I'll divide it by 10. Now tell the new quotient is 1, 2, 3. What's the new remainder? New remainder is 4. Everyone has to agree with this. In the next step, what I'll do is I'll take the previous quotient, that is 1, 2, 3. See here how I'm taking. First input I took. IP means input. What was the input? 1, 2, 3, 4, 5. I took input first, I divided by 10. I got a quotient and remainder. Next time while dividing, I'm not taking the original number, I'm taking the previous quotient. Again, I'll do divided by 10. What is the quotient now? 1, 2. What's the remainder now? 3. Agree? Because if I divide 1, 2, 3 by 10, the quotient is 1, 2 and remainder is 3. Again, I'll take the previous quotient. 10. What is the new quotient? It is 1. What is the new remainder? It is confusion still here. Okay. Okay. I'll not stop here. Again, I'll take 1. I'll divide by 10. What's the new quotient now? What's the new quotient when I divide 1 by 10 is 0 because it cannot divide 1. So what's the remainder? 1. Next time, remainder is 1. Next time, I have to stop. Why? Because my quotient has become 0. If you see carefully in the remainder, I'm getting all the digits 5, 4, 3, 2, 1. On adding the reminders as and they come. So what I'll do is I'll create another person called sum. Create another person called sum. Initially, I will make my sum as 0. Nothing is there in it. Next time, what I'll do is my sum is equal to sum plus remainder. Just write this statement. So what happens? What is the value of my sum? Previous sum. What is previous sum? 0 plus remainder. What is remainder? 5. So answer is 5. Next time, the answer is 5 here. Next time, what will happen is, again it will do previous sum. Now you can see my sum value has become 5. Previous sum plus remainder. So what is the answer? My sum is equal to previous sum is 5 plus my new remainder. What is the new remainder? 4. So it will create the answer 9. Next time it will do 9 plus 3, 12. So here your sum will become 12. Next time 12 plus 2. It will become 14. Next time 14 plus 1. It will become. This much mathematical steps we are doing in our brain. When someone is giving us 1, 2, 3, 4, 5 and telling us to add, our brain is so fast to do this. In our brain, we are not having a section to store reminder. We don't have a section to store quotient. We don't have another person to do addition and all. Quickly, my brain is going to do this. Correct? The neurons are working so fast, they're able to do this behind. and I'm quickly able to tell this. But they are also doing the same procedure in one or the other way. Fine. How is it picking digits? First, it takes 1 plus 2. It's adding in the same way. So this particular thing has to be given in a logic form. So this thing, what I have written it, right, it's called as logic. And this is not computer science. Logic is purely mathematics. It's purely maths. So those who feel that computer science is very difficult for bio students, or bio students usually have complaints that it's difficult for me. No, it's maths. Computer science is maths. First of all, there is no branch called computer science in foreign universities. It comes under basic maths. Earlier also in engineering, we did not have computer science. Computer science came later part. If you see your principal and all, when they were learning, they did not have computer science. It comes under maths, statistics. It's a separate department of maths. Fine. This logic should come by common sense. So this is what your companies are expecting. Programming language may vary. C, C++, Java, Python, anything. Just syntax is changing. The syntax is changing. But this part is very, very important as a student. This is called logic. How do you solve puzzles and all. You see in WhatsApp and all, right? DP and all. Someone tells a puzzle, solve. Who will solve it? Your brain is solving it, but you're not writing the steps and giving it to your computer. So in future, whenever you're getting certain puzzles, right, try to code it and see whether you are able to write it in the form of a code. So this is the logic which we will now write as a code. I'll comment this part so that it doesn't throw me an error. So this much thing I need to do. So what I'm doing a repeated job. Find the quotient, take the remainder, take the quotient for the next step, go on adding the remainder. So I go on adding the remainder. At the last, I'll get 15. Okay. So see the code here. Initially, I want a number which you are reading from keyboard. So let me take it here itself. You can write a scanf and read. Fine. Okay. I want some persons to store the values. So who are those persons? I want reminder. So I'll write rem. I want a variable called sum. In your brain, we are not using it. We are quickly doing it. But computer needs to have someone to store the values temporarily and finally give us the answer. So what I'll write is, now I have the option of choosing while or for loop. Why I'm going for while loop is, use a for loop, I should be clearly telling what should be the increment. But it is very difficult to tell the increment. Is it incrementing by 1? How is becoming 1, 2, 3, 4, 5 to 1, 2, 3, 4? Is it incrementing by 1? No. Is it incrementing by 2? No. Operation. That means I cannot go for a counter controlled loop. I should go for an event controlled loop. What do you mean by event? Doing the job until my quotient becomes 0. That means there is an event called 0. Now 0 is called as an event. So there is an event called 0 who is responsible for stopping your program. It's not the counter variable which maintains the count. It's this particular event which makes your while loop stop, because it's not a counting. It's not incrementing by 1 or decrementing by 1 or incrementing by 2. It's counting. If it is counting, I could have used a for loop. Yes, first you take 1, then increase by 1, so it becomes 2, 3, like that. Now it is not counting. It's until the quotient becomes 0, go on doing this procedure of finding the new quotient, adding the remainder. That's why we go for while loop. So here what I'll write is, until my number not 0, I should do some job. What is the job which I have to do? Fine. Okay. First find the remainder. How do you find the remainder? Your number in computer science, for finding remainder, we have this one. Right? For quotient, it is divide operator. For getting remainder, it is this one. After finding remainder, add it to my previous sum. So initially, see here, my sum is not having anything. I'll tell that concept also. So add it to my previous sum. If I don't write any value to it, it's a local variable. So computer will give garbage value. What happens in your computer memory is something or the other is stored. Or the other is stored. It's like, if I have to give an example, something in your fridge is, we store something in the fridge. If a new item comes, I need to remove the old item and I should put the new item. I should put the new item. Until I remove the old item, it will be having some garbage thing in there. It will be having some things there. Fine. I should empty it when something new is coming. It will be having that old thing only, whatever is kept. So in computer also the memory is like that. It will not be having all blank spaces. It would have stored something was written previously. When you request a memory space, it will remove that old thing and will give the new thing. It's like how, renting a house. Someone old will be there. When you have been given a house, that old person has to go and you are the new person entering the house. So something or the other will be there in the memory. So usually the computer will have some wrong values. And before using a variable, you should either give it a default value. So that's why I'm giving it a default value 0. You have a question, why I'm giving 0? Sum is involved in addition. So we know the concept in maths. Any number will not change its value. Adding 0 to the number will not change its value. So that's how we give default value. So you should be very careful while giving default values. Default value, because my sum is used before giving him some value. You can see here, first time if I use my sum, and if I don't give 0, it will take some old garbage value it was there in the memory. Whenever there is anyone who is being used without giving any value. Num, I am not giving him any value here because he's been getting the value from the input. Reminder, I'm not making him 0 because he is not used in the operation. He is getting the answer and then he is used. So whatever old value he is having, this particular operation will erase that and will give him a new value. Not making him 0. Sum, I'm making him 0 because before I get a value, he himself is getting the value from the same variable, that is sum. That's why I need to make him a default, giving it as 0. Why 0? Because it's involved in addition. If it was multiplication or thing, I should be giving it as 1. Why? Because multiplying 1 to any number will not affect it. Since it is involving a value 0. Okay, next, updation. See, this is a body part. What is a body part happening? Collect the remainder, go on adding. What is the updation? Next time when you're dividing, take your num as not the old num, take the new num which you obtained after dividing by 10. This is my step. Whatever I wrote here, 3 lines, the same thing I have written here. First take the remainder, add it. Next time before you go, make sure that you're taking the new quotient. Okay. Now let us see whether I'm getting the answer. Printf sum is equal to %d \n, and where is my sum stored? It is stored in SUM. What I gave 1, 2, 3, 4, 5. So let me run. I should be getting the answer as 15, or else my logic is wrong. See, I'm getting 15. Okay, you may think it is working only for 1, 2, 3, 4, 5. So let me give my input as 6. It should give me 21. See, 21. This is how the logic works. This is how you write math logic. It's completely maths. But how do you write it? How do you understand it? That's your common sense. How do you give it to your computer? How do you feed it to your computer? You should be knowing how the computer is giving values, how the computer is storing values, how the computer erases the old value and stores the new value. So these things are very, very important when it comes to writing logic in computer science. This is a simple logic. One more question, similar logic what you can use is, and most of the time these logics remain same. It's just your common sense to use it around. They give a number, you should write the reverse of it. You should write a reverse of it. Logic. What I do is, when I get a number, the previous sum I'll multiply with 10 and then I'll add remainder. So what was the previous sum? 0. So I'll multiply it with 10. So 0 into 10. So what is the answer? 5. Next time when 4 is coming, See here, I'll erase these things. I'll tell you the new logic. I'm not directly adding. Next time when I'm finding sum, I should take previous sum, that is 5, multiply it with 10. Then I should add the new remainder. What is the new remainder? 4. What is the answer? 50 plus 4. So what is the answer? 54. I should again take 54, multiply it with 10, and then add the new remainder. What is the new remainder? 3. So it is 543. Same way, in the next attempt, I should take 543, I should multiply it with 10, then I should give him the new remainder. What is the new remainder? 2. So what will be the answer? 5432. Same way, 543, sorry, not 65432, 5432, because 543 into 10 is 5430 plus 2, so 5432. Fine. Okay. Next time, what I'm doing, 5432 into 10. So what is the answer? 54321. See, I got the reverse. This is how you write the logic. Simple logic. Maths I've used. And star and plus, you know, you apply Bodmer's rule, right? First, you need to do multiplication and then addition. That's the rule in maths also. And the computer science also, we follow the same rule. This is a logic. Simple change I have done. So see the simple change here. I'll just make sum into 10. Now see my answer. I gave input as 1, 2, 3, 4, 5, 6. My answer is 6, 5, 4, 3, 2, 1. Reverse of a number. Very simple. The same logic I used for adding the numbers, the same logic I'm using for reversing a number. Any number I give, it will reverse. 7 if I give, and if I run, it tells 7, 6, 5, 4, 3, 2, 1. 1, 2, 3, 4, 5, 6, 7 I gave. Okay. Same way, one of the standard question which we ask is check whether the given number is palindrome. What do you mean by palindrome? Palindrome. 1, 2, 2, 2, 1 is palindrome. If you take the number from the front or if you read from the reverse, the number is going to remain same. So what we need to do for that, your number has gone getting divided and your number becomes 1 and at the end it becomes 0. So you should previously store your number somewhere. So what I'll do here is I'll use another person called T who will store my number. So in the T, what I'll do is I'll just make my T equal to my initial number, temporary variable with 10 to hold num. Why I'm using num to be in T? Because my num will lose its value when I'm go on dividing. At the end, what I'm checking is to tell whether it is palindrome if is equal to sum. And it is a palindrome. So I'll just print palindrome. Simple. We'll give input in a palindrome and we'll see. We'll give 1, 2, 2, 1. So it should tell it is a palindrome. I'll run this code. See, it is telling it is a palindrome. Okay. If I give anything else, it will not print palindrome. See, it is not printing palindrome because 1, 2, 2, 1, 3 is not equal to 3, 1, 2, 2, 1. So this is another example of checking whether a number is palindrome or not. You can check characters also. Malayalam, Madam, all those things are actually palindrome strings. So you can check with that also. So this is where you loop your things. When you have a repeated thing to be done, this logic is repeated 5 times. But I don't know whether it is repeated 5 times or 6 times. It depends on number of digits. If I know clearly that it is done 6 times, then I would have used a for loop. If I clearly know it has to be done 10 times, I should use a for loop. But now it depends on my input number. And I know only one thing. The while loop should stop when it becomes 0. That's why I use while loop. I don't use for loop. Because the event makes it stop. The event is becoming 0. But for loop is not like that. It's a counter. You know counts, right? You 10 times I have to do. You know first only. Any number it comes, I should do 10 times. Then it is for loop. But if you don't know how many times I need to do, it depends on your input. Then it is while loop. Because it's depending on input. It depends on an event. So that's where you come a difference of event controlled and counter controlled loops. Okay, let me see on few questions if I have anything. Can we give labels on loop? Shreyas, yes. What kind of labels you want to give? Yeah, if you are telling about go-to things, you can label a loop also in go-to. No problem on that. Yeah, but don't use go-to anywhere. Your program will abruptly jump from one place to another place. So it's not a good habit of using go-to. Go-to is to be used, and I said right in places like where you want to come back to the home page. When you use web development and all, they have their own versions of go-to. In C programming, if you are writing an animation program where there are different levels of scenarios, and you want to come back to the first scenario back, so you will give an option to him. Press 1 to go to first level, press 2 to go to second level. In that case, if you press 2, you should return a level at the label at the second level. So that's why it goes back. Because after 2, again, it should come back to 3, 4, 5, and again, it should ask, do you want to go back to the previous levels? So that places and all, you can go for using go-to. So that's why we use go-to. Or else avoid using go-to, exit, and break and continue. Be careful when you're using. Fine? Okay. One more small program I'll take, which tells the program is just print even numbers in a given range. So someone is giving you a range, X to Y. To print all even numbers in that range. Print all even numbers in that range. That's your task. Fine. Okay. So what's the example? Let me take an example. Someone is giving you 1, 2, which 2? Now it depends whether you want to take boundary also, like 1 and 10 also if you want to include or if you exclude. This example, print all even numbers in between the given range. Don't include the boundary. Sometimes it will print all the even numbers in the given range, including the boundary values. Then include 1 and 10 if required. Okay. Now we'll not include the boundary values. So 2, 8, it should get printed. 3, 5, and 7, it should be ignored. How will I do it? See here. Now I know 1 to 10. I know the range. It should start from X. It should go till Y. No one can stop it. So that's why I'll go for using a for loop. Use an integer. I know X value. What is your X value? So your I'll make him as X. So what is your X? 1. Should be less than 10. If it is boundary value, if its boundary value is not to be included, then you should, to be included means you should use less than or equal to, and here you should use 1. If you want to ignore boundary value, then you should use 2. You should start with 2. Now I'm telling ignoring boundary value, so I'm starting with 2. I'll write I++. Now, inside what I'll write is if I reminder. How will I know it is an even number? I'll divide by 2. If the remainder is equal to 0, equal to 0, then only I should print. What I should print? I. Or else I need not print I. So this is how I have written the logic. See? For I equal to 2, I less than 10. That means I start I with 2. Why I'm starting with 2? Because I said don't include boundary values. If you want to include boundary values, then the answer will have 10 number. In that case, you should make less than or equal to. And I should start with 1. That depends on the question how they have given. Then if it's divisible by 2, I'm printing it, or else I'm not printing. So if I'm including boundary values, my answer should be 2, 4, 6, 8, 10. See, 2, 4, 6, 8, 10. Perfect. Okay. So now what I did is, if someone is a company guy is asking you a question to print all the even numbers in a given range, and if I write this answer, he may not select me. He may not select me. Why he may not select me? Clear, right? if I want to write the answers for this, I should know the first even number. If it tells that exclude the values, I can write first even number, that is true 2, and I'll not write I plus plus. I'll write I plus equal to 2. If only. Directly write printf. This is how you can actually reduce your lines of code. I. Now if I run this program, 2, 4, 6, 8, 10, I'm getting the answer. What I did is, earlier it was incrementing one by one. Now I know the logic that even number means always it is increments of 2 starting with the first even number. So that's why I gave I equal to 2. Next, I'm incrementing I by 2. So first time what happens, your I is equal to 2. I will become 4. Next time I will become 6. Next time I will become 8. Next time your I will become 10. Earlier what was happening is your I was 1, then your I was 2, then your I was 3, then your I was 4, then your I was 5, 6, 7. So it goes on continuing until your I is equal to 10. You can see number of body part also has got increased. So it would have taken around 10 seconds if I tell. It would have taken only around 5 seconds. So as I said in the previous section also, your job is to reduce the time of the computer taken to do the job. So how do you train your mind? How do you do maths fast? You have some loop CET, those are written CET exams and all. They'll tell, right? Longest integration problem is there or differentiation problem is there. How do you have a trick to get the answer? But if you write it in second PU exam, you may end up in getting 0 or 1 mark. But in CET, you will get the full answer. That's like applying a trick. So that's your logic part. In writing computer logics also, you need to be reducing the number of lines. And there comes your thinking, brain power. And that is completely maths. Computer science. Computer science is just giving you syntax. But company is not looking for the guy who is good in syntax. Company is looking for the guys who are good in. So train yourself to improve your maths. So a good person who loves maths always is a better programmer. So usually mechanical students are little good programmers. Only thing is they have in a mind that programming is not their cup of tea, so they don't code. But if they start coding, they are the good programmers, mechanical and civil students, because they usually deal more subjects in maths. Calculation formulas and all are more in mechanical and civil compared to computer science. We don't touch maths only after first and second year, but mechanical civil have maths till their final year, calculations and all those things. So they are actually good programmers if they learn programming. So that's what I have to tell. Anything else? There are many ways you can solve one program. Can't we use array? You can use arrays, but it's a thing which how you solve the program. As I said, right, there are different ways of solving a problem. Which is the best one? Consider when we tell best. Who is taking less space and who is doing faster? There comes your all knowledge of computer science and then maths. So there, if you think arrays can do it faster, arrays are better, then go for arrays. If you think loops can do it, then go for loops. So it depends on your space and time. Arrays thing we'll see it in the next session. I've kept it for the next session, hopefully. Yeah, data structures and problem solving extras, we have kept it for the next session. I'll take up there. Arrays, structures, unions and all, I'll take up there. And nested for loops also, I'll keep it for the next session because we have come to the end of the session. So we'll keep it for the next session. Any questions specifically if I have to answer, you can raise your hand, then the volunteers can give you access, or I can wind up the session. Sorry for the glitch in the beginning. I can't help it out in any way. The network connections were poor, maybe due to weather conditions. But hopefully at the end of the session, I think we were in good connection. Any questions? There are a few questions I've shared for solving. I think volunteers will platform where you can access it. No questions? So we can stop, volunteers.
Okay, thank you, sir. Thank you so much. Even after facing so many technical issues, you did it. Like, you came to the end of the session. So we'll have our next session. That is the last session next Friday, and
So are
then
we having it on next Friday?
yes, sir. Next
It's
Friday.
a Christmas Eve. So see, Christmas
Oh,
Eve, I guess. Yeah. So I'm asking.
okay. So we'll get back to you, sir. We'll confirm it and we'll get back to
Okay.
you. Okay.
Okay. Fine.
Okay. And all the winners will be getting ladus from CodeChef. Like, using those ladus, you can avail the goodies and stickers. And whoever have joined today, especially the CET people first year, so welcome to our community. We are a bunch of people who are very interested in coding and competitive programming. So any doubts you can clarify texting in the WhatsApp groups, and then the questions will be out within few days, so you can all try and practice and then get back to us if y'all are stuck. So thank you for joining today's session. Thank you, sir.